Sir Isaac Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless an unbalanced force acts upon it. The first example in our video of this shows you two objects. The object at rest is the skateboard, and Evan, whom is in motion, is the unbalanced force. Since the force of the object at rest is less than the force being applied by Evan, the unbalanced force of Evan will cause the skateboard to move. One other thing to keep in mind is when Evan jumps onto the skateboard, the wheels stick to the top of the board due to friction. Because of this, Evan is transferring the energy he had when he was in motion onto the skateboard. This causes the skateboard and Evan to be in motion. As you can see in the next clip, Evan goes from gliding across the cement to roughly rolling down the hill. Both Evan and the skateboard are in motion until reaching zero velocity at the bottom of the incline. His speed reduces due to friction between the wheels of the board and the rough, uneven ground. This is showing how an object in motion will cease to have motion due to the unbalanced force of friction. Newton's second law of motion states that the force of an object is equal to its mass times its acceleration. In this example, you can observe Evan launching out of the bowl and quickly returning to the ground. A change in motion occurs only if a net force is exerted on an object. Gravity, being the net force acting upon Evan and the skateboard, changes the motion of him by pulling him to the ground. Since gravity's force is going towards the earth, the skateboarder changes direction in which the net force is going. The last example we have is of Andrew riding a longboard down a hill. Due to gravity, Andrew's combined mass with the skateboard is being pulled down to the center of the earth. The acceleration can vary due to multiple factors of friction. Andrew's acceleration is dependent on his mass. The more mass there is, the harder it is to accelerate. Since he is going downhill, he is constantly accelerating due to his mass, the gravity acting upon him, and the angle of the incline. Newton's third law states that for every action, there's an opposite and equal reaction. We can find an example of this in skateboarding using the most basic trick, the ollie. An ollie takes place when someone jumps with the board while it remains under their feet. Now, in the example, if you look closely, Andrew bends his knees and then kicks his leg down into the ground in order to counter his weight force. By applying his weight force and the extra force he added to jump up, he then receives an opposite reaction from the ground, which is called the normal force. This second example is kind of harder to see than the rest of them, but it's the most important function of skateboarding. Skateboarders call this pumping. Pumping is when you are going down a ramp or going into a turn in the bowl and you bend your knees and push down on the board to stand back up. The outcome of this is that you get a little speed boost. Why does this work? It works because when you are skating down the ramp or into a bowl, you already have gravity carrying you to the ground, which will already make the skateboard continue to move. But when you reach the bottom of the ramp, bend your knees, push down, you're adding the force you pushed, weight force, and acted force together to push against the ground. And according to the third law, the ground is going to give you a normal force equal to all the forces acted against it. Therefore, it pushes you with the same force you applied against it, causing you to go faster.